so 10 megabits is a bottleneck. So how do we get data and power beyond reach without dumping the port down to 10 meg? And hi tech lovers, welcome back to our baseball park. Today's video opens on the same baseball complex you saw in the last episode. Remember that long distance Pt.2 camera we push out past 200 meters? We use that PoE++ BT switch, drop in link speed and turn on CCTV mode. Squeeze every meters we could out of the copper cable. It worked great for the video because Pt.2 only needed around 10 megabit per second. But today is a whole new game. And now our clients want Wi-Fi way out by the far batting cages, more than 150 meters from the building. We all know over 100 meters, power over Ethernet voltage drops and your Ethernet signal starts to decay. So the challenge becomes really simple to say but hard to solve. Data plus power beyond reach. And now you might be thinking, can we just flip the CCTV mode on the BT switch again? Negative. CCTV mode on those long-range BT switches usually forces the port down to 10 megabit per second. That's perfect for a single camera stream, but it absolutely chokes a Wi-Fi access point. So a modern WAP can push up to hundreds of megabits, especially if you've got players uploading videos and maybe a scoreboard system running over Wi-Fi. So 10 megabits is a bottleneck. So how do we get data and power beyond reach without dumping the port down to 10 meg? And here's where the hero of today's video shows up, the PoE extender. Now think of a PoE extender as a pit stop on a long highway. Power and Ethernet travel down the cable, they hit the extender. Then the extender regenerates both voltage and the data signal, then send them out again. And you don't need an extra power outlet where the extender sits because it's powered by PoE from the switch side, then passes that along. And the one we're using today is our outdoor 1-in, 2-out PoE extender. It takes one PoE input, then gives you two PoE outputs, and it's designed for gigabit data. It can also work with 802.3 AF, AT, and BT standard PoE. With a high-power PoE++ source, it can deliver up to 60 watts in total, 30 watts per port, which is perfect if you want to fit a Wi-Fi access point and maybe a nearby camera from a single extender. So now let's look at our full setup. So inside the main building, all the camera recording happens on an NVR. That NVR is already plugged into our 480 watts PoE++ switch along with the indoor surge protector in the rack. And from there, we jump onto a 10G fiber out to another 480 watts PoE++ switch. And from this field switch, we are going to run a 100 meters copper to our extender. So let's plug it into the PoE++ port so we can send both power and data. Now we are going to mount our extender on the demonstration board. So I'm taking out the neck and the gland for faster installation. All we need is screws. So let's mount it on our demonstration board. And one more to keep it stable. All right. Now we are going to connect the 100 meters Ethernet cable to the PoE input port of our extender. Then I'm going to run this 50 meters cable from the PoE output port, either one of them, directly to our Wi-Fi access point. All right. So now we can see our Wi-Fi access point is getting both power and the data. And the indicator light is on. Now, one thing is, you don't have to put our extender exactly at 100 meters. That's the theoretical limit, not a magic wall. So the idea is you can place it where it's protected, accessible for maintenance, and still within a comfortable budget for power and signal. And here are some tips. For cabling, use pure copper Ethernet cable. And for Cat5e or Cat6, that's outdoor rated. Also, tighten that cable neck and gland by using a wrench to fasten them, so the rubber seals compress around the cable jacket. And also, don't daisy chain extenders blindly, because every hop introduces some loss and consumes power from the PoE budget. If you're planning more than one extender, then you really want to sit down and calculate the power requirement of each device, the input power of the switch, and the cable gauge. And what if your Wi-Fi access point is truly remote, like way beyond what even multiple extenders can do comfortably? Then you can pull a single mode fiber as far as you need. And at the far end, you can drop in a media converter, so you can convert from fiber back to Ethernet, because fiber carries the data over long distances with almost no loss. So now that we're settled down with all the solutions, let's talk about something that's just as important: smart VLAN design. And we don't want the CCTV traffic yelling over the Wi-Fi in our system, so we need VLAN. VLAN isolation equals quiet channels. A VLAN is like giving different groups in our ballpark their own private hallway. Cameras walk in one hallway, guest Wi-Fi walk in another, and your management traffic has its own path too. And they all share the same physical switch, but logically, they're separated. And to do this, you must use unmanaged switches, because unmanaged switches don't understand VLAN tags or trunk ports. Now we need VLAN tagging, where each Ethernet frame can carry a little label that says, I belong to this or that VLAN. And we also need trunk ports. They're the links between switches that carry multiple VLANs at the same time with those tags attached. So now let's do it. First of all, we need to connect our computer to our field switch directly using Ethernet cable. Then we can type in our switch IP address. It will ask you to type in the username and the password. Then you just hit login. After login, you can see everything on this switch. Just go on to VLAN config. Under VLAN config, we have the VLAN ID. We are going to create a VLAN ID. Let's say this is VLAN 10, and we can name it CCTV. Then we can edit. Now we have VLAN 10, and it's called CCTV. Then go to port config. Now we are going to select our CCTV's port. Here we have port number 6. And maybe you have other cameras. Let's select 5 and 4 as well. And those ports are going to go under VLAN 10. Let's hit apply. So now we have those ports under VLAN 10. Then we can create a VLAN 20, let's say it's for Wi-Fi. Edit. Now we have the VLAN 20. Again, go to port config. Now we are going to select our port. This is port number 2 connected to our Wi-Fi access point. And go to VLAN 20 and hit apply. So it's pretty easy, right? And you also have to select the trunk port. Now we can select the port here. This is port number 25. Here, let's click on 25, and we can turn it into trunk port. This is our fiber port. After turning it into the trunk port, now it can allow all the VLANs 10 and 20 tag across that link. So here we can see our port 25 is already turned into the trunk port. Now on the core switch, we have to mirror that idea, and the fiber port is also the trunk port, allowing VLAN 10 and 20, and the ports feeding cameras are access ports in VLAN 10, and the port feeding our Wi-Fi access point is our access port in VLAN 20. So our Wi-Fi access point and all its clients live in the Wi-Fi VLAN, completely separate from the camera network. And the most important thing is, before you exit the web page, make sure you hit the save button so you don't lose your configuration. And now let's bring the NVR into the picture with a dual NAC setup. Now we chose an NVR with 2 network ports. Dual NAC NVR equals clean traffic flow. We have one NAC faces only the camera, and the other connects to the main network. So by the way, when you're setting the VLAN tag on the main switch here, make sure you set the port connected to the NVR into VLAN 10 so you can get access to all the cameras. So here we have NAC number 1 on the NVR plugs into a port on the PoE switch that's in VLAN 10. So all the camera stream flow directly between the cameras and the NAC 1 on the NVR. And the NAC 2 goes to the main network or a management VLAN, and that NAC gets an IP on the normal LAN. So that's how we expand a Wi-Fi access point 150 meters and keep a full gigabit backhaul and isolate CCTV from Wi-Fi at a real-world baseball complex. For now, this field is live, the Wi-Fi is strong, and the cameras and clients are finally playing nice together. Now thank you very much for joining us. Before you go, please don't forget to hit subscribe and like our videos. And I'll see you in our next one.